So continuing on with this problem, they tell you where P1 is the actual heart attack rate for middle-aged men, like the ones in the study who took this the gym pill, I don't know. And P2 is the actual heart attack rate for middle-aged men in the study that do not take the placebo pill, that do take a placebo pill. No significance level was specified, all right, in this problem. So they're stating that they're going to use 0.01 to reduce the risk of making a type 1 error. All right, so a type 1 error would be when we say that there is no difference, but really there is, right? Type 1 is when I reject the null, but the null is true. So when I say that there isn't a difference, or this says that there isn't a difference, when I say that the pill does work, but really it's not working. So they want to reduce this error. So they go through the plan that we're going to do a two-proportion test. Random, the data came from randomized experiment. The total number of successes, heart attacks, those are what they're counting, and failures in the two groups are these, and they're all at least 10. So they're good. Due to the random assignment, these groups of men can be viewed as independent individuals. Individual observations in each group should be independent. So we don't really have to check the 10% rule because, again, random assignment. I told you guys before when we do random assignment in an experiment that it automatically kind of meets this condition of being independent. The do, since the conditions are satisfied, we can go ahead and perform this. Again, the very first thing they do is find our pooled value because our assumption was that P1 was equal to P2. When we do P1 equal to P2, we have to get this pooled C for our data. So they write out the problem with the right formula, they plug everything in. Remember that this is always going to be 0 and that you have the 2 there. All right, so they plug it in and they get this Z statistic of a negative 2.47. All right. Remember that they actually do care which direction this is, so it's only one sample test. Also know that a Z-score of negative almost 2.5, I'm pretty sure that my p-value should be significant, but I'm going to check it anyways because I did set my significance level so low. All right, so we know that our alternative is that it's shading this direction, so we take our normal distribution and we plot our Z-score of a negative 2.47. They find the area under the under the curve, or the p-value, to be 0.0068. Remember that you can find that using the chart, or I will remind you, even though I've told you a million times and you should know by now, normal CDF is going to find me the area under the curve here, and that my lower bound is going to be negative infinity, my upper bound here is going to be negative 2.47, my mean is 0, and my standard deviation is 1. All right, and so that's what they do, and they find this value to be 0.0068. But I knew that was probably going to be what happened because of my Z-score being a negative 2.47. We know anything outside of about 2 standard deviations puts me pretty unusual. So 0.0068 is less than alpha, so p-value of 0.0068 is less than my alpha of 0.01, so I get to reject the null. And the null said that the two were equal, that there was that P1 proportion of people taking the drug having heart attacks is the same as the proportion of people taking the placebo have heart attacks. But we get to reject this. So if we can say that they're not equal, we can prove they're not equal, then we get to conclude that my drug, the Gimbervazole, whatever, heart drug, actually does have an effect on whether or not people have a heart attack. And so that's kind of the conclusion. Since our p-value is less than alpha, the results are statistically significant. We can reject the H0 and conclude there is convincing evidence of a lower heart attack rate for middle-aged men who or middle-aged men like these who take this Gimbervazole than those who take only a placebo. So we can conclude or prove that our drug is actually lowering heart attack for middle-aged men like the ones in our study. All right, so here's our summary. We learned that shape, center, and spread and how to get it. We learned how to do a confidence interval